Welcome back. Today we are working on rotations day number 3. Our content objective is students will be able to perform and describe how to rotate figures 270 degrees counterclockwise on a coordinate plane. So we've gone over 180 degrees counterclockwise, we've gone over 90 degrees counterclockwise, so the last one we're going to go over is 270 degrees counterclockwise. The language objective is students will be able to explain verbally how they rotate figures on a coordinate plane. Why am I learning this? Well, it's important for real-world problems like the creation of video games. So a couple background knowledge that I want to go over is remember that rotations are basically when you're rotating a figure around a fixed point. Okay, now another thing I want to go over is some of the coordinate rules of the types of rotations that we have gone over. First one was 180 degrees counterclockwise. We knew that the coordinate rule was we could take the opposite of x and the opposite of y, and here were some examples. We take the opposite of each one, leaving us with negative 2, 3. Here we would take the opposite of each one, giving us 1, 5. Now the other type of rotation that we've also gone through is the rotation of 90 degrees counterclockwise around the origin. Forgot to specify that it is around the origin. That rule is you go ahead and switch the x and y values, and you also have to take the opposite of the y value, the old y value, which is the current new x value. So here are some examples. Again, we are going to switch them, but we take the opposite of the new x coordinate, leaving us with negative 3, 2. And again, here we're going to switch the ordered pairs, and then we're going to take the opposite of the new x coordinate, which is technically the old y coordinate, leaving us with 5, negative 1. Okay, so now that we've reviewed that, we're actually going to go ahead and jump into the very first example for 270 degrees counterclockwise. So the whole point of the next 3 examples is we're going to really figure out what the pattern or what the coordinate rule is. By looking at some examples of 270 degrees counterclockwise, we're going to look at the ordered pairs and see what exactly is happening every single time. What is the coordinate rule? What is the pattern? So first thing you're going to have to do is write the ordered pairs down. So here we have h, which is 3, negative 1. We have h prime, which is negative 1, negative 3. We have m, which is 3, negative 3. We have m prime, which is negative 3, negative 3. We have n, which is 2, negative 1. And we have n prime at negative 1, negative 2. So taking a close look at the ordered pairs, I'm noticing one particular pattern. I'm noticing that the ordered pairs have been switched. So be on the lookout for that. So with that said, let's look at some more examples to see if you can find anything else that's happening other than the ordered pairs being switched. So on this note, I'm going to go ahead and have you pause the video and check numbers 2 and 3 on your own. Okay, so let's see how well we did. For number 2, hopefully you got the following order pairs. C was negative 5, negative 3. C prime was negative 3, 5. F was negative 5, 0. F prime was 0, 5. N was negative 3, 0. N prime was 0, 3. Sorry, N prime. P was negative 2, 1. And P prime was negative 1, 2. Let's look at 3. Here are the ordered pairs. B was negative 5, 2. B prime was 2, 5. I was negative 3, negative 3. I prime was negative 3, 3. Z was negative 2, 0. And Z prime was 0, 2. So with all of those ordered pairs, I'm going to go ahead and merge them all onto one slide. So here, this was from number 1, this was from number 2, and this was from number 3. Were you able to develop a coordinate rule for a 270 degrees counterclockwise rotation? I already hinted that I noticed that the ordered pairs were switched. Now, was there anything else happening? Yes, there is. Hopefully you recognize not only are the ordered pairs switching, but we are also forced to take the opposite of one of the ordered pairs. Now, was it the first or the second? Let's take a look. Here, this did switch, and if we did switch it, it would have led us to, let's say, negative 1, 3. But you see the result is actually -1 comma -3. So you're going to find that we actually had to find the opposite of the second value, which is the new y coordinate. So here you are supposed to take the opposite of the new y coordinate, aka the old x value. So you're going to find that the coordinate rule for a 270 degrees counterclockwise is they do switch, except you're going to take the opposite value of the new y coordinate. Now be very careful. This is extremely similar to a 90-degree counterclockwise. So let me break this down for you. For a 90-degree counterclockwise, you're going to find that we do switch y and x. However, we take the opposite of the y. For a 270 degrees counterclockwise, again, it is a switch with the y and the x. However, with the 270 degrees counterclockwise, you take the opposite of x. So this is where things get a little bit tricky because you're going to have to remember which one goes with which. So here's my way of making sure I remember which one's which, because it is kind of tricky. What I think of is first I have to memorize that with a 90 and 270 degrees, it is required that the ordered pairs switch. So from there, I decide, okay, what's bigger, a 90 or 270? 90 is obviously smaller, and for that reason, that's why I take the opposite of the first value. Then when I go to a 270 degree rotation, I understand 270 is larger than the 90 degree, so that's why I take the opposite of the second value. Now that's just my way of memorizing the rule. You can totally come up with your own. If there's something better, that's great. However, if you feel this would suffice, feel free to use this method. Okay, so now we're just going to go ahead and move on. Let's go ahead and write down the actual coordinate rule in our notes. So here, for a 270 degree counterclockwise rotation around the origin, we're going to find that the coordinate rule is they are switching, except we do take the opposite value of the new y value, aka the old x value. So let's go ahead and practice some. So here we have 2, 3. What I'm going to first do is go ahead and switch the values, except I'm going to have to take the opposite of the x. Sorry, not the x, the new y value, which is going to make it a -2. So after the rotation, we're going to end up with 3, -2. Let's try some more. So again, first we're going to have to switch the ordered pairs. So I'm going to end up with -5, -1, but I'm going to have to take the opposite of the new y value, so that's going to make it a +1. So of course I would want you to rewrite this as -5, 1. I would want you to put a +1 in front, a plus symbol. Okay, so now another example. Here, once again, we're going to switch because it is a 270 degrees counterclockwise. So we have 5, -4. We are going to have to take the opposite of the new y value, so that's going to make it a +4, leaving me with 5, 4. So notice again, I am rewriting it because I don't want to have that plus in front of the 4. Now last but not least, once again with the 270 degrees counterclockwise rotation, we're going to go ahead and switch the two coordinates, leaving us with the 0, 7. I am going to have to take the opposite of this new y value, aka the old x value, leaving me with a -7. Okay, so now that we've practiced that in isolation, let's go ahead and move on to the next portion. For number 4 here, it says the following points were rotated 270 degrees counterclockwise. Write the coordinate pair of the pre-image and image. So already they gave us the pre-image, so our job is to find the coordinates of the image. So here, if we are asked to rotate it 270 degrees counterclockwise, our coordinate rule will have to be, first of all, they are going to switch. So it's going to be y, x. And so here's where I'm thinking, okay, do I take the opposite of the first or the second? Well, since 270 is larger than 90, I'm going to go ahead and take the opposite of the second. So this is my coordinate rule. So let's go ahead and practice for d prime. I'm going to switch the values. Now switching a -5 and a -5 didn't make much of a difference, but it did happen. So now I'm just going to have to take the opposite of the new x the new y value. So this makes it a positive. So my final answer, I would say, is d prime is negative 5, comma 5. Whoops, there is my final answer. Okay, so now moving on to the next one, f prime. Again, we're going to go ahead and switch the values. So now I have 1, comma 3. I am going to have to take the opposite of the new y value. So now that's going to leave me with f prime is 1, comma negative 3. Okay, just keep chugging along. For here, m prime, we are going to switch the x and y coordinates, so leaving me with 1, comma negative 7. We are going to have to take the opposite of the new y value, so the opposite of negative 7 makes it a positive, leaving me with m prime, which is 1, comma positive 7. Now, last but not least, with q, which is 0, comma 5, I'm going to say q prime is the reverse. So we're going to put 5, comma 0. And then I'm going to have to take the opposite of the second value. There's no such thing as a negative 0. So this is actually my final answer. Q prime is just 5, comma 0. So we went ahead and practiced the 270 degrees counterclockwise in isolation. Now for the challenging part. Now I'm going to go ahead and mix all of them together. So far we've learned 180 degrees counterclockwise, 90 degrees counterclockwise, as well as 270 degrees counterclockwise. So now it's going to be all mixed together, and we need to figure out which rule to use and when to use it. So here for number 5, it says write the coordinate pair of the pre-image and image given the following rotation. So for A, it's asking us to go ahead and rotate it 90 degrees counterclockwise. So here, 90 degrees counterclockwise, that's definitely one of the switches. So I'm going to go ahead and write, okay, so it's definitely going to be y, comma x. Now using the method that I've developed, I'm going to go ahead and say, okay, since 90 is smaller, I'm going to take the opposite of the first value. Now if it was 270, I would say, okay, 270 is bigger than 90, so I would take the opposite of the second value. So that's my rule. That's one I developed. Again, feel free to come up with your own if you feel like there's something that works better for you, but that's what I'm going to be using. So here for d prime, I'm going to go ahead and switch the values. Now negative 8 and negative 8, switching them doesn't make much of a difference, but like I said, it does happen. I'm going to go ahead and take the opposite of the the new x value, so this is going to make it a positive 8. So I'm going to go ahead and say d prime is positive 8, comma negative 8. Okay, so now let's move on to the next one. Now they're asking you to do 180 degrees counterclockwise with point F, which is at 4, comma 7. Now 180 degrees counterclockwise, please don't let this confuse you. This is one of the easier ones. There's no switching at all other than to take the opposite of each coordinate. So here I'm going to go ahead and say F prime. We're going to take the opposite of 4, which is negative 4, and the opposite of 7, which is negative 7. Please remember to not switch. The coordinate rule for this is just going to be the opposite of x and the opposite of y. Okay, so no switching. Okay, moving on to the next one. Now they're asking for 270 degrees counterclockwise for point M, which is at negative 3, comma 7. This is definitely one of the switches. So I'm going to go ahead and write that the coordinate rule is going to require me to switch. So it's now y, comma x. Now I got to think, okay, what's bigger, 90 or 270? 270 is definitely larger, which is going to be the reason why I'm going to take the opposite of the second coordinate. Okay, so here I'm going to go ahead and switch the values. So now I'm going to be left with 7, comma negative 3, but I'm going to have to take the opposite of the second value, aka the new y value, giving me a positive 3. So I'm going to go ahead and say m prime is 7, comma 3. So that is my final answer. Okay, so last example here. Now they're asking us to once again take a 90-degree counterclockwise rotation on point Q, which is at 9, comma 0. So 90-degree counterclockwise, that's definitely one of the switches. So I'm going to go ahead and write it's a y, comma x. Then I'm going to ask myself, okay, is 90 bigger or smaller than 270? Definitely smaller. And for that reason, I'm going to take the opposite of the first value. So I'm going to go ahead and put Q prime is the switched version. So I'm going to put 0, comma 9. We're not done. We have to take the opposite of the first value, aka the new x value. there's no such thing as a negative 0, so I'm going to go ahead and leave it as q prime is 0, 9. So now that I've given you a couple examples, is your turn. I'm going to go ahead and have you pause the video so you can go ahead and try E all the way through L on your own. Okay, so let's see how well we did. I'm just going to go ahead and quickly go over the answers. So here for E, we have A prime is negative 1, 9. For F, we have Z prime, whoops, let's try this again. For F, we have Z prime is 6, negative 3. For G, we have T prime is 8, negative 2. For H, we have W prime is 1, negative 5. Moving on. For I, we have B prime is negative 10, negative 2. For J, we have E prime is 1, 6. For K, we have H prime as 4, 7. And last but not least, for L, we have K prime as negative 9, negative 8. So I'm hoping you did pretty well. However, if you did not, please feel free to go back into the first examples that I went over, A through D. Please go through the lesson one more time so we can make sure that you have this down, whether they're asking for a 90, a 180, or 270 degree counterclockwise. So again, please feel free to go back in the video if you need a refresher, if you didn't feel confident with these rotations. But if you're ready to move on, let's go ahead and actually get started on performing a rotation of 270 degrees counterclockwise. So here, the very first thing that we always do is start with what we know. It says here, triangle ABC has vertices A, 1, 0, B, 3, 3, C, 5, 0. Rotate triangle ABC 270 degrees about the origin counterclockwise. So, like I said, we always start with what we know. So I know the pre-image, the order pairs are given right up here. So I'm going to go ahead and say A is 1, 0. B is 3, 3, and C is 5, 0. For a 270 degrees rotation, it is one of the switches. And again, the reason why we're taking the opposite of the second is because when you compare 90 and 270, 270 is larger. So that's, again, my way of thinking. You can totally, once again, come up with your own. If you feel there's something better or you see things differently, that would be great. So here, I'm just going to go ahead and perform the rotation. I'm going to go ahead and switch the values, leaving me with 0, 1, keeping in mind that I do have to take the opposite of the new y value, aka old x value, leaving me with a negative 1. So here we have 0, negative 1. Here I'm going to go ahead and write A prime. Now moving on to B prime. Once again, we are going to switch the values because it's now B, negative x. So we're going to put 3, 3. Now switching them didn't make much of a difference because they're the same exact numbers. But like I said, it did happen. Now we're going to go ahead and take the opposite of the new y value, so that becomes a negative 3. So I'm going to go ahead and plot the point 3, negative 3 here at B prime. And then last but not least, for C prime, we're going to switch the values to go ahead and put 0, 5. We are taking the opposite of the new y value, so that's a negative 5. So plotting that point 0, negative 5, we'll put C prime right here. So at this point, I can go ahead and connect the points together. And there is my figure after 270 degrees counterclockwise rotation. Now, it's always important that we keep in mind that with rotations, we do preserve certain characteristics. Rotations preserve what? We always look at 3 particular characteristics. So let's take a look at them again. We always look at shape, size, as well as orientation. So let's take a closer look. Are both of these shapes the same? Absolutely. They're both triangles. In fact, they're the same type of triangle as well. Now, are they the same size? Yes, they are exactly the same. Now, are they the same orientation? No, they are not. The angular positioning has definitely changed, so orientation has not been preserved. Now keep in mind that whenever a shape and size is preserved, basically what's happening is it's creating congruent shapes, which means corresponding sides are going to be congruent and corresponding angles are going to be congruent. Now we are going to go a little more into detail with that in future lessons, but I do want to kind of pre-expose you to those concepts that these figures are indeed congruent. Now with that said, I'm going to actually have you move on to the next example and go ahead and rotate this triangle 270 degrees about the origin counterclockwise. Okay, so let's see how well we did. Hopefully you went ahead and wrote down the coordinate pair for A, which is -1, -4, and figured out that A prime is going to leave you with -4, 1. B is 1, -1. Here it's given in the instructions, and hopefully you came to the conclusion B prime is -1, -1. For C, which was 3, -4, hopefully you came to the conclusion that C prime is -4, -3, all of which these points were derived from this coordinate rule. Then hopefully you went ahead and plotted the points on your graph and connect the points together, and this is the triangle you should have ended up with after the 270-degree counterclockwise rotation about the origin. And it's always important that you state that the shape remained the same, the size remained the same, but the orientation was not preserved. And yet again, whenever shape and size is the same, the figures are congruent, meaning corresponding sides are the same and corresponding angles are the same. And that is going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!